composite figures. So a composite in general, it is just, a figure which you could cut it up into at least two or more. All right, for example, this one, it's a rectangle and a trapezoid. This one is a parallelogram and two half circles, right? And so forth. So these are examples of composites, okay? And that's what we're gonna be focusing on today. I do ask you guys for you to watch this video over the weekend or at some point before Monday, okay? Class will start at 8:30 on Monday, and ideally, I'm just gonna answer questions on whatever you did not understand, okay? So again, make sure you watch the video, and this is area of composites. All right, so a composite figure again is a figure that can be broken up into multiple basic shapes. Number one, we have a rectangle, and then we have some type of trapezoid underneath it. Okay, so they're telling you that this is 23, that from here all the way over here is 18, and that this is 12 and this is 15. So again, it's going to be very important that you notice, sorry guys, something fell down, I don't know what it was, that you notice that this 18, right, like if this is 12, then this is 12. And then knowing that that's 12, this other missing piece will ultimately determine the height of the trapezoid. Okay, so again, notice how there's two shapes. There's the rectangle and there's the trapezoid. So maybe the best strategy when working these out is to just see them separately. So I'm going to go ahead and redraw them. So we have a rectangle where this is 23 and this is 12, and we have and to find the area of a rectangle, it's just base times height. Okay, it's going to be very important you really understood the assignment from this past week, because that's going to tell you what formula to use. Anyways, to find the area of a rectangle, it's just 23 times 12. Okay, so it is just 23 times 12. So the area of the rectangle is 276. Now we need to find the area of the trapezoid. Well, the trapezoid, we know this is 15. We know this right here is 23, because if this is 23, that's 23. And the height, well, again, if that's 12, that's 12. The whole thing is 18. 18 minus 12 is 6. So the height right there is 6. Area of a trapezoid is the B1 plus the B2 times the height divided by 2. And so it's just going to be 23 plus 15 times 6 divided by 2. And we just get our calculator, and (23 plus 15 times 6 divided by 2). And so the area is 114. All right, let's check this. Sure, you guys can hear me. Yep. All right. And what was that? Nothing on there? No. Okay. So if you wanted to find the total area, we would just add up these two, and that's it. So the total area is 114 plus 276. The total area of this composite, I guess I'll write it down here. 390, and the units centimeters squared, right? Don't forget the units. I don't always write them down there, but they are very important. So again, please realize how it all started. We had basically two shapes, broke them up, found the area of each one, added them in the end, and then that was it. Number 2. So on example number 2, let's see if I could draw this one. So we have a parallelogram, and then we have some semicircles. Let's see. Okay, something like that. They go ahead and they make a nice 90-degree angle there, telling you that this is 5. They tell us that the radius is 6 inches. Alright. And so again, you need to see the different shapes. So here we have our parallelogram, and we have our semicircles, which it is important to note that these two are exactly the same thing. They're just, separated. And they're semicircles. So you could think of it as, even though they're two halves, in the end, it's just one. So our parallelogram first. In our parallelogram, we currently know that our height, right, this distance going like this, right, our height is 5. And the distance from here to here, right, the base, well, if this is 6, this is 6, so this has to be 12. And in a parallelogram, area is just base times height, so this would just be 12 times 5. So the area here is currently 60. For the semicircle, or again, you could think of it as just a complete circle, right? Because there's the two halves, they make a 1. The radius is 6. And to find the area of a circle, it's just pi radius squared. So it's just pi 6 squared. Okay. So it is just, 6 squared. And whatever I get, I multiply it by pi. Right. Or again, I could have just done it from the beginning, put everything together. It all depends what kind of calculator you have. But we get the same thing. So the area on this piece, it's 113. I'm going to go ahead and round to the nearest tenth. And now if I want to find the total area, it would be 60 plus 113.1. So I just have to add them together. So the total area is 173.1. And again, the units, let's not forget those units, inches squared. And the units, they don't affect the magnitude, but they affect the overall units. Even that you were building something, that would be very important. So that's number 2 right there. Let's do number 3, and I hope you're seeing the gist of it. Okay, so on number 3, we have a semicircle in the bottom. We have a rectangle, and we have a triangle, a right triangle. Okay, so again, keep in mind the shapes that you have. It's very important you understand the shapes that you have. and what the numbers represent. That 7 is actually that distance right there. Okay, so we have again a right triangle, a rectangle, and the semicircle. 3 shapes. So we're gonna go ahead and do 3 different little area problems. So first up, I'm gonna go ahead and do the rectangle. If this is 9, you would expect this to be 9, right? Notice how everything is 26. Um, and here's the tricky part. If you know, right, that this is 9 right here, then what would you expect when you're working on the semicircle? What do you expect your radius to be? I mean, it's kind of like no the part. And if you know what the radius is, then what do you expect? Let's see if I have a different color. I don't know how to distinguish this. What would you expect this distance to be? Think about it. Wow, I look for my blue Sharpie. I have a blue Sharpie somewhere. Think about it. Alright, I found it. And again, if you know that this little piece is 9 and this is your radius, well, from the center to the edge, that's your radius. You would expect that to be 9 as well. Okay, and I guess I'm going to start with this one first. I already drew the picture and everything. Area is usually pi r squared, but this happens to be half a circle, so I'm going to have to divide by 2. So area is pi 9 squared divided by 2. When I plug it in my calculator, pi 9 squared is 81, okay, and then I have to divide it by 2. So my area is 127.2. Still going to round to the nearest 10. You can keep that in mind. This 9 is very important because now you know that from here to here, that's 9. And if everything is 26, 26 minus 9 is 17. So we know that this has to be 17. So when we're trying to find the area of the rectangle, we know this is 9 and we know this is 17. And that's more than enough information to be able to calculate the area. It's just 17 times 9 or 9 times 17. Doesn't really matter how you write it down. And so the area here is 153. Let's see if you could see that. You can still see that. Okay. So again, so far we have the area of the rectangle, the area of the semicircle. Now we just need to calculate the area of the triangle. Okay. We need to calculate the area of the triangle. Well, in the triangle, we know that the bottom part has to be 9. And this little piece, well, if this was 17 and this is 7, this has to be what? Yeah, 10, right? 17 minus 7, 10. And now, again, we have enough information because area of a triangle is base times height divided by 2. 10 times 9 divided by 2. The area of the triangle, 90 divided by 2 is 45. And so our total area is going to be the sum of these 3 now. So my final area is of 325.2. Okay, and these problems, guys, again, they're not going to be hard, but when we're doing the composites, they are a little bit longer, just because you have to think of the different shapes that we're dealing with. Okay, so again, the three shapes, the work I had to do to find the individual areas, and then I just combined them. Okay, so again, very important you understand how to use the area formulas for the basic shapes. All right, let's do another one. Oh, let's clear history. All right. So you get the idea there with that. Here, number 4. This is a good one. This talks about one of those problems that a lot of you guys were having issues with. So we have another semicircle, and again, there was a lot of problems on question number 8 on the assignment from last week. You guys were having a hard time finding the area of a semicircle, and you were also having a hard time finding the area of a triangle when they didn't give you the height like obvious. But anyways, so the two shapes here, right? This is my favorite ice cream cone type thing. I don't know if you guys know which one it is by the color. So these are our two shapes, the semicircle and the triangle. So again, if I first find the area of the semicircle, the 16 represents this whole line, it's your diameter. So your radius is 8, right? And again, area of a semicircle, we already said it's pi r squared divided by 2. So it is pi 8 squared divided by 2. The area of my semicircle is pi 8 squared divided by 2, right? So I have here an area of 100.5. Now for the triangle has no clear height, but we know it's an isosceles triangle. So you can create this line yourself, and this line actually cuts everything down the middle. So if this whole thing was 16, and we already know that this piece was 8, so it's obvious that's 8, and this piece is 8. Just focus on one of these triangles. It's a right triangle. This is 8, this is 17. To find your height, Pythagorean theorem. I know my C, and so I must subtract. So we have 17 squared minus 8 squared. My height is 15. Keep in mind this 15 is not area, it represents the height of the triangle. When I'm trying to find the area of the triangle, base times height divided by 2, well, my base is not going to be 8, it's going to be this whole part, it's 16. My height, I just found out for it to be 15. And again, when I put it in my calculator, 16 times 15 divided by 2. It is 120. And again, the units happen to be meters here. And when I want to find the total area of these two shapes combined, it's just the 100.5 plus the 120, which in this case will give me 220.5. The units are meters squared. That's it. All right. That's how you go about it. Area of composite, guys. Okay. Just break up the shapes. That's all it is. There'll be problems, guys, like number 4, where you have to do Pythagorean theorem to get the extra information. Okay. Um, that's something that you guys need to be able to be like, oh yeah, I do Pythagorean theorem there. I know, I see it. Okay. It's a must. Okay. It's not always, they're not always going to give you everything, right? So you need to do some work at times. On number 5, just a little heads up, you will need to do some work of some kind before you could just plug in numbers, right? Number 6, the shaded regions. Okay, area of shaded regions. Okay, so let's see. Yeah, I'm gonna go ahead and do number 6 and number I guess number 9, and then that'll be it. Okay, 6, 7, and 8, they all revolve around the same thing. I want you guys to notice how there are essentially 2 shapes. Okay, on number 6, you guys have the square and the circle, and they only care about the square part, right? So all you need to do is you need to find the area of the square, and you already know this is 25, and since it's a square, that's 25, that's 25. And you might be wondering, sir, how do you know it's a square? Well, because it's a circle. Okay, your diameter is 25, your diameter is still 25. Okay, so the area here of the square is just 25 times 25. When you're trying to find the area of the circle, well, again, we just said that the diameter was 25. So that means your radius is half. So let's find out what's what. So 25 times 25, that's 625. And 12.5 squared, that gives me 490.9 if I round to the nearest tenth. And keep in mind, they want the shaded region. The square is bigger. I'm taking away the circle part. So that is essentially all you have to do. The area of the shaded region here is 134.1. And again, units, feet squared. Sorry, okay. So the next one I wanted to talk about was number 9, just because again, it's multiple shapes put together. So on number 9, you guys have a shape that looks something like this. And then this happens to be a semicircle. So you know this is 17. You know this is 25. And actually, it just depends on how you see it. Okay, when I first saw this, I'm not gonna lie, I first saw a triangle, a rectangle, and a circle. I saw 3 different shapes. But if I think about it, if I just ignore this piece, this is a trapezoid. Okay, so I'm actually going to do the same thing I did for number 6. I am going to work with the 2 shapes that I see here. this green trapezoid, okay, and the semicircle. So for the trapezoid, I am going to have to do a little bit of work here. I know this is 17, I know this is 37, and I know this is 25. But do we know our height? It is not 25. Our height is the distance between these two parallel sides. It's basically this line right here, but there was nothing here. You are allowed to just do that. But again, we still don't know it. But now I have a right triangle. If from here to here was 37 and that's 17, this has to be the missing piece, right? So again, if that's 17, that's 17, so this has to be 20. I have a right triangle, or because I know my hypotenuse, essentially I'm going to have to subtract just to find my height here. And this is just something that must be done at some point. So the square root of 25 squared minus 20 squared, and it's 15. I now know that this is 15. I now have enough information to find the area of the trapezoid. 17 plus 37 times 15 divided by 2. Okay? So 17 plus 37, that times 15 divided by 2. So the area of the trapezoid is 405. Now that we know this was 15, we know this is 15. So when I'm finding the area of the semicircle, my radius is half of that. Okay, and half of 15 is 7.5. And again, I recommend when using the calculator, even if you're at school, right, just press Control Enter, it takes care of it. So pi 7.5 squared this area here is of 176.7, and because they wanted the shaded region, and the shaded region was most of the trapezoid, all I'm going to do is just subtract again. 405 minus 176.7. My final area of the shaded region is 228.3, and the units were inches, so inches squared. Okay, so again guys, you guys could please make sure you watch this video. By the time we go around it, okay, it's just a matter of being able to use the formulas. Okay, you can use the formulas, you will be fine. Okay, expect me to assign you here on the composites and the shaded region. Okay, all right guys, so I hope you're having a great day while you're seeing this, and enjoy. Okay, see you around. Bye bye.